In the Arctic Circle, this team of elite engineers is embarking on an epic endeavor.
It's a very, very big operation.
In just 5 years, they're attempting to construct a remarkable new superstructure. The longest suspension bridge ever built in the Arctic Circle.
We have only one chance to build this bridge.
Constructed from more than 11,100 miles of steel cable and soaring over 580 feet into the clouds. The team must battle extreme heights.
They need to be very, very careful when lifting.
And surging 80 miles per hour winds. To complete this 5,029-foot-long bridge before the winter weather strikes.
The weather can be extremely tough.
It was a dramatic situation. Actually, we're quite scared.
This groundbreaking bridge ranks in a league of ambitious new engineering wonders that are bigger, faster, taller, and more advanced than anything ever constructed before. This series charts the inside story of the extraordinary challenge of building these giants. Northern Norway, deep in the Arctic Circle. In this part of the world, icy mountains soar high into the clouds and plunge deep into the freezing waters of the Norwegian fjords. The remote industrial city of Narvik, a crucial hub for fishing and mining iron ore, sits to the south of the giant Rombak Fjord and has a population of around 14,000. But the stunning landscape here also creates a problem for residents. A killer commute. To access the north, they must drive a treacherous winding road, 11 miles around the edge of the fjord. Rockfalls and landslides often kill and injure motorists along this route.
The road around the fjord is very dangerous in the winter.
This road is not so easy to drive. There have been a lot of crash on this road.
So to save lives and cut commute times, engineers are planning to build an ambitious new crossing over the water called the Hålogaland Bridge.
This green line indicates where we are building a new bridge, and it means that we will have a much more safe road, a shorter way, and we don't have to use this old one that is exposed for rock slides.
Conceiving its design rests on the shoulders of structural engineer Jamal Assad. It must be able to span the 980-foot deep fjord and still survive the bitterly cold environment.
The bridge will improve the whole infrastructure in this region. I've been working on this bridge for almost 10 years to create something unique, not just for this area, but also around the world.
This is the giant Jamal and the team must somehow construct. Twin A-shaped towers, built from over 42,000 tons of concrete, will rise from the bottom of the fjord. 2 huge cables will hang between the towers. Each cable weighs 2,000 tons and measures more than 1.5 foot thick. The cables must hold up a custom-made, dual-lane road deck, made up of 30 steel sections. Each cable will be anchored over 150 feet deep into the heart of the mountains on either side of the fjord to hold the bridge steady through the roughest weather. Stretching almost 1 mile across the water and costing £332 million, the giant Hålogaland Bridge will be the longest suspension bridge within the Arctic Circle. But the northern location makes building this bridge extra tough. The Arctic environment is brutal Temperatures here can drop below -15 Celsius, and 80 miles per hour winds race between the mountains.
Bad weather can cost a lot of money.
If not built right, the results could be catastrophic. Suspension bridges are extra susceptible to the force of the wind, making the construction of this bridge an extraordinary challenge.
You can see that all these hills give a climate which will be challenging to construct a bridge.
Yes, so that's one of the things that we have to clarify.
Building this one-of-a-kind bridge in such a uniquely hostile location involves a series of complex stages. On top of 4 huge pillars, the team plan to build up the massive A-shaped concrete towers. Then they'll carefully winch 80 wire strands 566 feet up and across the freezing fjord. These will form the 2 colossal main cables. Next, they will jack the 2,000-ton cables apart by 51 feet in the center of the span and attach 110 steel clamps and vertical hanger cables. These will hold up the 30 aerodynamic steel sections that will form the 7,000-ton road deck. Finally, workers must race the winter weather to lift each section of deck into place to create almost 1 mile of roadway between the towers. For Jamal and project manager Dagron Kassen, it's going to be a real battle against the elements.
It's quite a challenge to build bridges in this part of the world. We have the dark time of the year. We do have all kinds of weather.
Dagron heads up a team of 900 engineers and workers from Norway and across the world. None of them has ever attempted a bridge on this scale in such a remote part of the world before.
So challenging, but altogether we have an amazing team. We will make it happen.
Dagron's first challenge: construct the bridge's giant reinforced concrete towers. Building work begins in 2013. King of concrete, Guttorm Reidar, must erect the towers at high speed. To do this, he uses an ingenious technique called slip forming.
You can reach about 2.5 to 3 meters each day, and you work 24 hours a day.
Workers fill a special mobile mold that clamps around the leg of the tower with concrete. Once each layer of concrete is set, hydraulic jacks raise the mold up to the next level so the towers continue to grow 8 inches at a time.
You constantly pour concrete, and when the concrete are cured enough, you lift the slip form a little bit to you have enough space to pour in new concrete on the top.
The team pour the concrete non-stop, 24 hours a day for an entire week. Over 32 months, they raise the towers to their full height of 566 feet. Then they build out the concrete viaducts from the shore to the towers.
These projects have been the most difficult because the weather can be extremely tough.
In this part of the world, temperatures will rise and fall by 40 degrees Celsius across the year. This dramatic change leaves engineers facing a big problem. The entire 61,000-ton structure will expand and contract with the changing seasons.
The moving could damage the concrete.
Changes in temperature cause the concrete approach road to grow and move. Expansion and contraction of the concrete could create devastating cracks and eventually bring down the approach road. To prevent this, the team has built the road and tower in separate disconnected sections. And Guttorm has installed 2 ingenious slide bearings between the road and the base of the tower. As the seasons change, This innovation allows the concrete to slide over the tower as the approach road expands and contracts. This will ensure that the concrete structures don't tear themselves apart and should keep the bridge open all year round.
I'm checking the slide bearing. The whole viaduct has moved 1.5 centimeters, but it will shrink and expand depending on the temperature.
With the slide bearings working effectively, the team tackle their next colossal challenge: installing the bridge's mammoth 5,774-foot-long main cables.
The cables is the one that will carry the weight of the bridge deck and the traffic load. So this is a very important part of the bridge.
But making cables that are strong enough to suspend over 12,000 tons of weight is no simple task. Each main cable is made up of 40 strands. Each strand contains 127 individual steel wires and weighs around 50 tons. Workers use winches and pulleys to drag each strand one by one up and over the tall towers.
This is actually quite a milestone for the bridge when they start pulling these cables, so we are very excited. In a good day, they can pull up to 3 strands, but the average is 1 strand each day.
But with less than half of the main strands in place, the Arctic weather begins to wreak havoc. Deadly winds batter the wires.
Wires are moving and dancing around. The west cable was actually blown over to the east cable and hitting the other cable. So it was a dramatic situation we were in, and actually we're quite scared for the bridge and for the wires that they were damaged.
So the team evacuates the bridge.
I had the feeling that the tower was moving, so then we thought it was best to get down.
The following day, the deadly winds die down, allowing the team to continue to secure and compress together the wire strands to form the bridge's massive main cables. At either end of the bridge, they anchor the cables into the ultra-tough Norwegian mountains to hold them steady.
Mother Nature built our anchor blocks and we used them. We are now in the anchorage hall. This is the very end of the bridge, where the anchorage of the main cable ends in a massive concrete wall.
To make the anchor's base strong enough to hold the bridge, the team has excavated a cavernous chamber over 150 feet down, right into the heart of the mountain. Inside, they've installed a massive 8-foot-thick concrete wall. To connect the bridge into the anchor's base, first they separate out the strands. Then connect them all to the tension cables that run down through drill holes to the wall where they're gripped tight. The wall acts like a giant brace. It uses the mountain itself to hold firm the weight of the bridge.
This concrete wall and the volume of the rock is actually what is holding the bridge.
With the bridge's towers and cables in position, the team face their next big challenge: construct and install its road deck. Suspending a road across this freezing 980-foot deep fjord is fraught with risk. Structural engineer Jamal must design a roadway that can withstand the ferocious Arctic storms.
The biggest challenge in this area is the wind. You have a lot of turbulence, and that's due to all these mountains. So for the bridge deck, you have to design for the wind speed where the bridge get unstable. And as a consequence, the bridge deck can get destroyed.
Strong winds can shake even the toughest suspension bridge to breaking point. This is the Tacoma Narrows Bridge, a two-lane suspension bridge built in the late 1930s across the Strait of Puget Sound in Washington state. After opening to traffic, the bridge began to shake in an unusual way. Wind passing over the deck caused it to oscillate violently up and down. The slender bridge was not robust enough to take such a battering, and just 4 months after opening, it collapsed.
With the narrow deck, you're working on the edge of aerodynamic stability.
Like the Tacoma Narrows crossing, Jamal's bridge is slender, built to carry just 2 lanes of traffic. But this super skinny design makes the bridge extra susceptible to strong winds.
The wind will create some curls, and you can have the bridge oscillating up and down.
As the wind gusts over a bridge from one side, it travels above and below the road deck. A change in air pressure forces the wind to curl backwards in the other direction as it clears the opposite edge of the deck. This process is called vortex shedding. These wind curls, or vortices, begin to move the deck up and down. They can cause the bridge to oscillate and twist violently. To prevent this, Jamal is designing the edge of the deck on his bridge to have a special aerodynamic shape. It smooths the flow of wind and reduces the vortices. His design should help this bridge remain steady when hit by the strongest gusts.
So one way to mitigate that is to limit this angle to below 16 degrees. Then you can avoid any vortex shedding phenomena.
The bridge's deck is being built in 30 custom-made sections in this factory in China. Each section is made from around 250 tons of steel and is hollow to cut weight. The completed deck sections are transported 12,000 miles by ship from eastern China to Narvik port in Norway.
The vessels from China have arrived, and this is a big moment for us and also for the local people here.
Steel engineer Kurt Grunstad is anxious to make sure that the deck has survived this epic voyage.
Finally, we have the steel elements in Narvik. We have waiting for them for many, many months now.
Kurt's team need to carefully remove the hefty steel columns used to secure the deck sections onto the ship. This is a high-risk procedure.
Removing of the sea fastening is a very, very big operation. It's a high column and it starts waving and it can hit the section, so we have to do it very, very carefully. Because if they get damaged, then it takes 3 years to make new segments.
Denting or smashing any section of deck could put the entire project back by months.
Every one of the workers are very concentrated, and they do it slowly, slowly.
The giant supports slowly clear the danger zone. Kurt must now check each section for damage from the inside. Any holes or rust could compromise the integrity of the entire bridge.
Now we look in the first part of one of the section inside, and it's painted and it's cleaned. If the section had been filled with seawater, we can have a lot of rust, and I can see that there is no rust in these sections.
The arrival of the deck marks a major milestone for this project. But there's a problem. Winter is rapidly approaching, when plummeting temperatures and ferocious winds will strike this region. To stay on schedule, the team must install the entire road deck before winter arrives.
If we don't get the bridge deck up by the middle of October, we have a larger risk for high wind speed and bad weather. So we have to work for this to happen before the winter sets in.
The first task, fit the crucial 110 hanger cables that will hold up the segments of road deck. Giant clamps are designed to secure these cables in place. Workers test that each clamp is able to hold around 7,000 tons.
It would be a problem if the cable clamps start to glide. A fatal collapse of the bridge decks could be the result. What's the model? 47. Yeah. Okay. Great.
With the clamps checked, the team then ship each hanger cable from the shore to the bridge by barge.
We have 110 hangers to install, and we must work fast.
This hanger cable weighs around 4 tons. And it's one of the longest, measuring more than 400 feet. Raising this humongous hanger nearly 550 feet above the freezing water will be no simple task. Yu Wei's team up on the bridge lower a winch line down to Yu Guiyan's team on the barge.
It's a good weather for install the hanger. No wave, no wind, and perfect.
With conditions looking good, they start the big lift.
Okay, we are ready.
We go.
2 meter from you.
Barge captain Oddbjorn Martin Luther keeps a close eye on the weather.
Yesterday there was a lot of wind. Today, tide is coming in, so I have to hold on.
Oddbjorn needs to ensure the barge remains perfectly steady on the water throughout the entire operation.
The most difficult is to keep her in perfect position, so they don't get problems on deck. Got a spot on the pillar here, can keep it in perfect position.
The barge team must make sure that the cable doesn't snag or knot as it uncoils.
We must be careful during the whole process. 听到，听到，听到。打钢铁！
To pin the cable securely into its clamp, they break out a hammer worthy of the Norse god Thor himself. With one final whack, this huge hanger is in position.
Okay, stop.
It's a constant battle to beat the tides and winds to install the remaining hangers before the Arctic storms bite. It takes 2 weeks of intense work to get all 110 hangars into place.
Ah, it's good, very good. We have finished. Good job, good job.
Every hangar is placed. It looks good. And this is a milestone because we are one step closer to getting the bridge deck installed now.
The team only has 7 weeks to install the bridge's 30 deck sections before tempestuous Arctic weather threatens to shut down construction work.
The deck installation is very critical because the uncertainty of the weather is increasing as we approach the winter time.
Before they can install the deck, they must push the bridge's 2 massive main cables apart.
We are under a lot of pressure to shift to main cables.
This is the problem. The width of the road deck measures 61 feet across. But because of the tower's slender A-shaped design, the main cables only sit 10 feet apart as they approach the top. As the cables slope downwards, they would start to obstruct the road. To solve this problem, the engineers plan to shift the giant cables further to be 51 feet apart at the center of the bridge. Their idea is to use a series of giant steel beams fitted with hydraulic jacks. These shifting beams will slowly force the cables apart by 3.9 inches per push. They must repeat this process until the cables are correctly spaced out along the entire length of the span. Site engineer Yu Wei oversees today's crucial operation.
Today is a big day. We have 7 shifting beams and we have 14 people on the site. Now we are ready to shift 2 main cables.
With beams and teams in place, they start the big push.
Hello!
It takes around 30 tons of hydraulic force for the jacks to slowly push the 2 2,000-ton cables apart, inch by inch. Once each jack is fully extended, the team must retract and reset them, ready to push again. It takes 6 hours to push the cables 13 feet apart. But just as they hit their stride, the wind picks up.
Hello, Kurt. I'm calling from site. Do you have any control on the weather forecast?
I can see on my screen that the wind speed will rise up to the limit that they can work on catwalk.
I see. So you need to make the decision to stop?
Yeah.
Okay, so the information we got was that the wind speed is rising. So we will stop the shifting and wait till the wind settles.
The increasing wind forces the team to down tools and abandon today's operation.
It is very important to face tomorrow, or we will run out of time.
With the team waiting to install the deck, this delay couldn't have hit at a worse time. They have no option but to return to base camp, where head chef Yang Geli is preparing this evening's meal for the Chinese members of the workforce.
这道汤在中国是很流行的，所有的人都喜欢。
Geli was specially flown in to give the 50 Chinese workers an authentic taste of home during the construction and keep morale high.
We have our chefs and we do the Chinese food here. For any person, they eat the same food for so many years, maybe 40 years or 50 years. To change the foreign food for just one year is impossible, I think.
On the menu tonight, egg and tomato soup, followed by beef with rice.
It's very good for our workers. If the food is not okay, I think no one will work.
After a busy day, the team finish up with a game of pool to recharge ahead of another day's work. The next day, there's a break in the strong winds. The team must seize this chance to finish jacking the bridge's main cables apart.
Now we have 54 meters, but we have 11 meters left. Oh. We have just 10 centimeters left.
Yue and his team work tirelessly through the day to haul the cables apart.
Okay. Now we have finished. The two main cables is 15 meters apart. 好嘞，好嘞，我们都丢完了哈，大家可以下班了。
Success. Against all the odds, the weather holds out. Now the most daunting work can begin, installing the bridge's road deck.
We have been waiting for this for 4 years. And tomorrow it's going to be lifted. It's amazing.
Lifting the sections of road deck into place will be the team's toughest challenge to date. Once they start, they must not stop until at least 3 sections are fixed into position.
It's extremely important for us to have the 3 deck segments on place, because when the 3 segments are on place, it's stable. And the forecast says it's going to be okay weather for the 3 next days. So we have this little time window with good weather, and we cannot have anything happen that delays this process.
To lift each of the 250-ton sections into place, they need to use this mammoth floating crane. It's called the Hålogaland. The Hålogaland is the biggest floating crane in the country. Its giant lifting arm soars nearly 400 feet high and has a lifting capacity of nearly 800 tons. But making sure they lift each piece of road deck into the right spot will take careful coordination as the vessels shift around on the water.
We have the ship with the bridge deck, we have the floating crane. So it's essential that both these boats are anchored correctly and safe.
This is the plan. The ship carrying the deck will connect to 4 anchor points in the water and 2 winches mounted below the towers. These winches will pull the boat back and forth into the correct position for each lift. The team also plan to connect the floating crane to both the anchor points and the ship carrying the deck. This will ensure that the 2 vessels move in unison in the water. The crane will then lift up each section to the cables. Then the team will connect them to their mountings. They must repeat this process, joining at least 3 sections together within the razor-thin window of calm weather, or the deck won't be stable enough to withstand the battering from the incoming storm. But doing this won't be easy.
The platform is ready to lower the... Yeah. The first lifting is a challenge because if the segments start waving, it can hit the catwalk. We have a lot of people here working, so they need to be very, very careful when lifting.
The first massive deck section lifts off.
Oh, it's coming closer and closer.
The crane slowly raises the first 250-ton section to its mounts. The team keep a close eye on the weather. A sudden gust now could blow the giant crane into the main cables and cause catastrophic damage.
So far, it's looked good.
They line up the deck, insert the locking pins. Now it's hammer time again. It takes over 3 hours to lock the first section into place.
Perfect. No pins are installed, so now they will disconnect crane and the lifting gear. I feel very, very great.
The first section of deck suspended from the bridge marks a major milestone for the team. But they're rapidly losing light.
One segment now and 29 to go now.
It's taken most of the day to position the first section of bridge deck. They can't afford any delays if they're going to beat the high winds. After 72 hours of exhausting work, they make their deadline.
It looks very good. We're gonna be safe.
With a hefty 750 tons of steel deck installed, the bridge is now robust enough to survive a storm. Over the next 3 weeks, the team ramp up the pace. They lift, haul, and secure the next 22 segments into place one by one.
Everything goes smoothly. I think it's okay.
But with just 18 days until the winter weather is due to set in, progress grinds to a halt. Strong winds and fast tides make it too dangerous to lift the last deck sections into place. It's a huge setback.
It is really frustrating, but hey, we're building the longest suspension bridge ever attempted in the Arctic, so you wouldn't want to be caught with 280 metric ton on the hook and then the wind would rise, you know, that would be a disaster.
The delays don't only cost precious time, they also threaten to push this £332 million project over budget.
The tugs, the anchor setup costs around 100,000 euros a day, so we're anxious to get started and install the finished installation as fast as possible.
With the strong Nordic winds raging through the mountains, the team has no option but to down tools and wait for calmer weather. Finally, after an anxious few days, the winds die down. Dagrun's team gear up to complete the last critical milestone.
Right now we are waiting for the floating crane to come into position to put up the last element. This is really exciting.
This is the moment they've all been working towards for the past 4 years. the floating crane carries the final deck section to the bridge. With the wind at bay, they seize their chance to start the final lift. The entire project hinges on this moment.
I think it's gonna fit.
But it will be a tight squeeze maneuvering this 131-foot-long piece into the gap. One wrong move could put the deck section onto a collision course with the rest of the bridge. The crane slowly raises the deck above the roadway. This gives the team some slack to connect the hanger cables.
When they release the crane, then it will come down. So this, I don't think we will have this difference in the height.
With the hangers connected, the crane slowly lowers the final segment down to allow the hangers to take the full weight. The moment of truth. Will the two sides of the bridge line up? With some gentle persuasion, the bridge finally joins together. For Dagron, Kurt and the team, it's a huge relief and the end of an epic journey.
We are finished! Yeah!
Today we can start walking from the north side of the bridge and go over to the south side. We have looking forward to this moment for a long time now.
To mark this momentous achievement, Dagron and her team make the very first crossing over the new bridge to celebrate with the rest of the crew.
First trip on the Hålogaland Bridge. I really want to thank every one of you who has participated with all your skills. Today we celebrate the Norwegian way with coffee and cake. So congratulations to all of us for this milestone. Thank you. Thank you.
The completion of the deck marks a key milestone in this ambitious £332 million project. All the major construction work is now complete. The team has poured 32,000 cubic meters of concrete, secured over 11,000 miles of wire into the mountains, and installed 7,000 tons of steel road deck.
This will be a landmark. So I can tell all my friends that I have been building this bridge. This will be a memory for the rest of my life.
It's quite a challenge to build bridges. It's quite special. So when I go back to sit in the office, I will miss these days.
Over the coming months, the team will wrap the cables to protect them from the elements and top the steel deck off with the all-important tarmac roadway to finally complete the bridge.
When we have this new road, it will be, I'm quite sure, saving lives.
For the residents of Narvik, today signals a huge step towards a more prosperous future for the area.
This bridge means that we can develop our city. This connection goes directly to Europe, and I'm very excited to see this bridge opened.
The brand new Hålogaland Bridge will cut journey times to neighboring cities and provide a safer passage north for the residents, ensuring Narvik thrives for generations to come.